All right, folks, we're going to look here at multiplying polynomials. All right, so the polynomial that we are going to be multiplying, the first polynomial, right, happens to be a binomial because it has two terms. The second polynomial we're going to multiply is a trinomial because it has three terms. A few ways of doing this. All right, so from my experience, I'm going to choose to show you this box method. All right. It's not my favorite, but it just helps out the majority of folks. Not all folks, but I think most folks, they appreciate this method, especially as our binomial gets bigger and bigger. Our polynomial grows, right? So once we start looking at 4 terms and 5 terms, this method is really going to help us out. So check it out. What we do is, because I have 3 terms, let me rescale that. I just shrunk. I'm going to put my 2x squared right there, my 3xy right there, and my negative y squared right there. All right, so notice I have 1, 2, 3 columns because I have 1, 2, 3 terms. If I wanted to, I could have had 1, 2, 3 rows. So it doesn't matter where you place these polynomials. This is just how I place them. And that's the good news. And the reason is because multiplication is commutative, so the order doesn't matter. I could have switched these 2 up because they're being multiplied. So the order doesn't matter. All right. Then we have the x minus y. We have 2 terms, like I said. So we have 2 rows here. And now this is like our traditional multiplication table. We're just going to be multiplying, right, each term of our first group with each term in our second group. So let's go ahead and multiply. So 2x squared times x gives us 2x cubed because we add the exponents since we have the like bases. All right, so we have 3 times 1 gives us that 3. I have an x times an x, so I have a total of 2 x's, so I have x squared, and I only have 1 y. All right, and notice I have different variables here, so that's good news. All I'm going to do is multiply them together and nothing changes. So I'm left with negative xy squared. All right, let's do the next group. So 2 times negative 1 gives us the negative 2. I have a x squared and a y, so I'm just left with x squared y. All right, let's continue the march. We have 3 times negative 1, so that gives us negative 3. And then I have only this x right here, so I have an x. And then I have y times y. So I have a total of 2 of those y, so y squared. All right, we have negative times a negative, so we got that positive. And here we have a total of 2 y's, right? Y times y. Here we only have 1 y, so we have a total of 3 y's being multiplied. So y times y times y. All right, another reason why I appreciate this method is because now it's easy to see where my like terms are, right? Everything's nice and organized. It's very easy to follow what we just did here. And now I could go ahead and combine my like terms. All right, so writing our final answer, we're left with the 2x squared didn't have any like terms. Sorry about that. 2x cubed, all right, that didn't have any like terms. Here we have 3 minus 2, so we get positive 1 x squared y. So remember, when we're combining these like terms, the variables do not change, right? Only your coefficients, those numbers in front, that's what you're adding and subtracting. All right, so again, the exponents don't change. They only change when we multiply, and that's what happened here. So here I had an exponent of 1. Here I had an exponent of 2. So when we multiplied, you add those exponents. So if you think you might forget that, write it down. Right? Write that down. All right, continuing the march, we go ahead and combine these like terms. Here, if it helps you, put a 1 right here. So you have negative 1 minus 3. So we have a total of negative 4xy squared. And then this y cubed was all by itself, didn't have a like term. So we drop that down. Plus y cubed. All right, folks, so hopefully that helps out. The big question, right, the $1 million question that students always ask is, how do I know when to stop? Well, let me ask you, do you have any more like terms? No. All right, so that's how you know we're going to stop. So what people like to do after this is they like to start making up math. So I learn new math all the time. All right, so don't do that. All right, so hopefully this helps out. If you have questions, let me know. And have yourself a great day.